We are all familiar with eclipses, at least all of you, because December 26, 2019, we had an annular solar eclipse. And I hope in the planetarium, not only planetarium at Calicut, there are various organizations across Kerala. In our Mananchara Square also, various organizations, Corporation of Calicut has organized massive eclipse observation program, and I am sure that none of you have missed the opportunity to see the annular solar eclipse, such a rare event. So what is actually an eclipse? Wait for it. Now, why an eclipse occurs? So this is, let us see the geometry of the eclipse. It's quite simple. So this is sun, and this is our earth, and this is the moon's orbit. The moon's orbit is not perfectly circular, but in fact it's not very elliptical, so we can approximate it to a circle. So let us, for our study's sake, let us make it as a circular orbit. So this is a circular orbit. Moon is moving around the earth in a circular orbit. We have the sun here, and if you join this thing, you are seeing that this is the shadow cone. This is the cone of, actually this is the cone of Earth's shadow, because light is falling and this is an opaque object, so it casts a shadow. So in either case, when moon is passing through this portion, actually we get what type of, because Earth's shadow will fall on moon, so we get a lunar eclipse. And when the moon is passing in this portion, then we get a solar eclipse, that is moon's shadow falls on Earth. But then you will see that since Earth is moving around, so moon is moving around Earth in an actual elliptical orbit, and Earth is moving around sun also in an elliptical orbit, these distances actually varies. SE, that is sun Earth distance, and moon Earth distance are not fixed. Sometimes actually these are when actually moon is at the perigee, means it is nearest to our Earth. Moon is at an apogee, which is farthest from Earth. So like that, aphelion, perihelion. So these things actually determine how long actually these objects like moon stays within the shadow or moon shadow falls on the surface of the Earth. So it depends on how much arc it has to travel. For example, if it would have been here, it has to travel a smaller arc. If it would have been here, it has to travel a larger arc. So the duration of the eclipse depends on the circumstances of the eclipse when the eclipses occur. So length of the shadow and all can be calculated from these formulae, geometrical formulae like EV, SBC, EV, and you can see, you can understand that EV is the Earth and the vanishing points. V is vanishing point, shadow vanishing point. So this is one length, and SV the sun vanishing point distance, and from this geometry you can calculate the length of the shadow. All these are, if you know the average distance between Earth and sun today, you can calculate the length of the shadow yourself. You don't need anything else. So this is the way. So that was what I was explaining you, the different circumstances of the eclipse. The sun is here, the moon is here, and the Earth at two locations. Earth is here once, Earth is here another. So what happens is that, see, every shadow has two parts. It has an umbra, that is a dark portion, and the penumbra, that is semi-dark portion. So if we happen to be in the penumbral, if the moon happens to the moon is fully in the penumbral, or Earth is in the moon is in the umbral, or Earth is in the umbral. In either case, that is, moon is in the umbral in case of a lunar eclipse, and Earth is in the umbral in case of a solar eclipse. So in that case, we get a partial. If it is fully inside, we get a total. If it is partly inside, we get a partial. If it is in the that is the penumbral portion, this other portion which is semi-dark portion, we get an eclipse, but rarely it is visible. It's not appreciable to actually. So you will just see there is some intensity difference, but you will not understand whether there is an eclipse or not. So we appreciate only two types of major eclipses, that is either it is a total eclipse or it is a partial eclipse, but then there is an annular eclipse. Why it happens? We will come to it. So sometimes what happens is that annular eclipse happens because at this particular position, the distance is such that the moon can block only a certain portion of the Earth, but it is blocking fully, but it could not block the full disk of the sun, full photosphere of the sun. It could not block. It is covering but it is leaving a ring surrounding it. So in such cases actually we get an annular eclipse. So all these are based on geometrical things, and that is what we will be seeing through as we learn, as we go on discussing about this particular phenomenon. So how many eclipses can occur in a year? So there are actually calculations. You have to do certain calculations. Why calculations are possible? Because see, on average there is a distance, mean distance between Earth and Sun, and Earth, based on that distance actually there is a period. This can be calculated from Kepler's laws of planetary motion. We will learn about it in future, maybe tomorrow. So once you know the period, once you know the orbit, some parameters get fixed. So when the parameters are fixed, what happens is that you can calculate based on the geometry gets fixed, and you can calculate when, at what interval eclipse can occur. Previously and today we have computers, you can actually for next 50 years, 100 years, 1000 years, you can, if the system remains in this particular way, there is no collision, no galaxy, nothing is happening in major, which is not predictable up till now. Nothing has happened like that. We can go on predicting eclipses. There is no problem. So based on all these calculations, actually people have predicted that minimum number of eclipses which is possible in a year is 2. And the maximum number of eclipses which is possible in a year is 7. So if the minimum eclipse occurs, both are solar eclipse. It can be partial, annual, total, or whatever it is, but both will be of the category of solar eclipse. And greatest number of eclipse which is possible in a year is 7. So it is varying between 2 and 7. It can't be less than 2, it can't be greater than 7. So this should be clear, this should be known to you. And among 7 also, we can have only 2 combinations. All this can be calculated. We can have only 2 combinations. One is either we have 5 solar and 2 lunar, or we have 4 solar and 3 lunar. So these are all fixed, and there is nothing which can go beyond this. So everything is calculable, and that is the beauty of astronomy, that it is a science, it is precise science, and these things can't apply to an astrology, and that is the reason actually we say that astrology is not a science. So let us see. Now you see the geometry of the eclipse. You see that moon is moving, earth is moving around sun, and the shortest distance is called perihelion, and the longest distance is called aphelion, and the plane of Earth's motion is called an ecliptic plane, which is orbital plane. The moon is moving around Earth, shortest distance is perigee, longest distance is apogee, and the orbital plane of the moon's motion around Earth and Earth's motion around Sun are inclined at an angle of 5.5 degrees, and the point at which these two orbits intersect are called the nodes, ascending node and descending node. So the condition of an eclipse is that it should be in the same site as of Earth and Sun. It should be between Earth and Sun, and it should also be in one of the nodes. So that is quite important. So the two conditions, that is the reason actually every month we don't have a eclipse. Why we don't have eclipse? Because it may be in the same line of sight, but it is not in nodes. Nodes are the point of intersection. So when do eclipses occur? Let us see. So eclipses are occurring, as we have already explained, that there is an umbral portion and the penumbral portion, and whenever you are inside the umbral you get a total or partial. Whenever you are in the penumbral portion you get a penumbral eclipse, but which is not very much appreciable. Let us see how this actually there is nothing special which is occurring in an eclipse. Nothing occurs. Everything is there always, and that to appreciate that, look at the next animation. See, so we have shadows falling because moon and earth are opaque objects. Sunlight is making it shadows to fall, and these shadows sometimes actually traces on the surface of the earth or passes through the earth's shadow, and this gives rise to eclipse. Let us see why the eclipses occur. Let us see here, and you see that I have shown you this with animations. Again with a line diagram it is seen. And what is the beauty of the solar eclipse, total solar eclipse, is that actually the sun is 400 times bigger than the moon. The sun and moon and earth are nearly at the same distance, but on average sun is 400 times bigger than the moon and 400 times further from the moon. So these two conditions, though may be called a coincidence, but these two conditions are together making the sun to be fully blocked under certain circumstances by our moon. And this opportunity gives us to see the beauty of this total solar eclipse. So what is the beauty that I will show you, but that is actually the condition. The sizes of the apparent sizes, the angular sizes, angular diameter of the moon and the sun matches, and that actually makes us to see the total phenomena, total eclipse phenomena, and that is what is shown to you. So we can have a calculations of actually finding out the angular diameter at various locations. So the formula goes something like this, that angular diameter by 206265. Now this is a very unique number. It is actually how many seconds are there per second in a particular degree. If you calculate it, you will find it. So it is a conversion factor, and then if you have this ratio, this is equal to linear diameter by distance. So if you calculate this, you get the angular diameter of a particular object, and using this formula actually you can calculate the angular diameter and various. So there are various types depending on actually this. I am showing you here. We have the sun here, we have the orbit of the moon, orbit of the earth, and we have the umbral region, penumbral region, and moon is somewhat inside the umbral region, moon is partial in the umbral region, and moon is in the penumbral region. In such conditions we have penumbral eclipse, in here total lunar eclipse, in here actually we have the partial lunar eclipse. So different types of lunar eclipse. Total lunar eclipse, the moon is entirely inside the earth's umbra. Partial lunar eclipse, the moon is partially inside the earth's umbra. And penumbral lunar eclipse, the moon is inside the earth's penumbra. Such eclipses regularly occur. Penumbral eclipses are quite frequent. We see in calendar today penumbral eclipse is there, but we don't see any change. We don't appreciate actually any changes there. Sometimes it is called pink moon or something, fancy names people give, but these are useless actually, because penumbral eclipses are never seen, though in intensity may be measured, just 10% variation in brightness. So you can understand that if your bulb's brightness vary by 10%, will you ever notice it? You will never notice it. So they are not so important, but they do occur because of this phenomena of umbra and penumbra. So different types of, now we have seen the different types of lunar eclipse. Let us study about different types of solar eclipse. So as I have said you in the geometry, what is the difference between lunar eclipse and solar eclipse? In lunar eclipse what happened is that the moon passes through Earth's shadow. That is the thing in the lunar eclipse. In solar eclipse what happens is that the moon shadow crosses the surface of the Earth. So moon is small compared to Earth, so it can't cover the full Earth as such. So sometimes it covers a portion of the Earth. Okay, so if somebody lies within the umbral portion fully, then it experiences a total. Most of the time actually either umbral portion is it doesn't happen that it lies our Earth lies completely in the umbral portion. Many a times it happens that it passes through the oceans, so people could not see it. So all these things are happening, but sometimes it does happen that it passes through landscape, like last time we had it from Calicut itself. So some portions lie in partially in umbra and partially in penumbra, and those portions actually experiences a partial eclipse. Portions through which actually the total shadow is there, the eclipse, total eclipse. Okay, so sometimes during the totality when the shadow is falling and moving, so because moon is moving, earth is moving, so actually the shadow also moves, and there are some people who spends lot of money, who takes a plane and who chases the shadow, who always remain inside the shadow and going at the speed, and they experiences the eclipse for a longer duration of time. These are all fancies. People do spend lot of money in all those things. So what happens is that this is actually the shadowy region where actually the moon shadow traces the surface of the earth, and we get the path of total eclipse. Okay, the moon is at the closest approach and blocks the complete face of the sun. So we get so under favorable condition actually it has been estimated and it has been found out that around 269 square kilometers of Earth's shadow is is traced on the surface of the earth is traced by the cone, shadow cone, because this is conical in shape, so it is called a shadow cone. And imagine the speed. We go in a car, maybe in a plane also we have a certain speed limit, but then this is moving, the shadow moves at a tremendous high speed of 1730 kilometers per hour. And so at equator, of course, its speed will vary depending on the latitude, and it goes up to a much higher speed of 8,000 kilometers per hour. Imagine 8,000 kilometers per hour at the pole. At that speed, actually, you can't even chase the eclipse as such. So all these things, all these wonderful things happen due to the celestial, because we are always on the motion. Now you are sitting in your house, you are sitting with relative to your house, but you are in motion in space, you are moving at a very high speed, so that is also free. Okay, so everywhere we are in motion, so those things are there. So we have a maximum duration of total solar eclipse. How long can you have? I said you how the duration becomes maximum and minimum, how much actually position, whether Earth is in perihelion or aphelion, or whether Moon is in apogee or perigee. So under such favorable conditions, when we have the maximum duration of the eclipse, it has been estimated and calculated and verified that the maximum duration of the eclipse is 7.5 minutes, and such an eclipse will be possible. It will be possible again on 16 July 2186, and in India we will be seeing it for around 7 minutes 24 seconds. And there will be one more date in which it is possible, is 5th July 2168. So these dates are in future, and we all will most probably not be here to observe that. Somebody else will be observing, but anyway we have actually the better ability to calculate and find out that such things are possible, and that is itself an achievement. Now there is one more type of eclipse which is annular, and I have explained you the geometry actually why an annular eclipse occurs. Why it occurs? Because, for example, when we are nearer to the sun, that is, Earth is in the perihelion position and the Moon is in the apogee, further away. So Moon's angular diameter is small, Sun's angular diameter is large. So the Moon, when it covers the Sun, what happens is that it could not cover fully if it is inside directly. So it leaves a ring surrounding the Sun, and that is the actually angular solar eclipse. So that is what is happening. So Moon's size smaller, and that is what I have explained here, is written here, and we get the annular solar eclipse. So types of eclipse we can summarize. We have partial eclipse, when the Moon blocks a part of the disk of the Sun through its path. So it can either be, we can either have a total solar eclipse or annular solar eclipse from any part of the world. But if it is total solar eclipse or annular solar eclipse for a certain part of the world, it will definitely be partial solar eclipse for all the other parts. That is the reason, not all the other parts, many other parts. But sometimes it happens that at certain same eclipse, somebody is seeing it based on the location. It happens due to various factors. Factors means geometrical factors. Based on these various factors, from some location, Moon is totally covered. At some location, the Moon may completely block, because it is in, these are borderline cases. And at other location, actually we get a ring. So it is in hybrid eclipse. So let us see this particular video. So you see that this is the disk of the Sun, and you see this is actually the Venus, which is crossing the disk of the Sun, and it's moving. It has occurred on June 8, 2004. We also saw this eclipse from Calicut, and many of you, I don't know, might have seen it from your hand, but that is what is called as a transit. So just imagine that this is the disk of the Sun. This is the disk of the Sun, and we have Venus, which is between Earth and Sun, and Venus is coming and it is passing along the disk of the Sun, somewhat like this. It is coming here, then it is coming here, and then it is fully inside, and it is moving like this, and then again it comes here and it exits from here. First contact, this is the first contact, this is the second contact, this is the third contact, so we have fourth contact. We record the timings T1, T2, T3, T4. Based on this and based on certain other parameters, we can actually determine what is the distance of Earth from Sun. So this distance can be calculated by detailed calculation. We can show the derivations and all, which we will not show. This is called 1 astronomical unit. Now I will show you one more video actually, where we will see a phenomena called occultation. Occultations are quite important, when actually a planet or a star is occulted, is lost from the vision from us by moon, or sometimes by asteroid, or sometimes by certain other planets. Sometimes the Galilean moons are occulted by the planet Jupiter. I'm sorry. So let us experience one occultation phenomena. Here it becomes dim and it has been made more faster, and it is going behind the moon. So the contrast is reduced. As such, what happens is that Saturn has gone behind, and after, so it has gone behind, it goes behind, then after a certain time, say broad, say 1 hour 44 minutes or certain time, again the thing comes out. So this is the phenomena of occultation. Welcome to the exhibit Eclipse, Occultation and Transit in our Astronomy Gallery at the Science Center and Planetarium. So in this exhibit actually we are explaining all the three phenomena together, and I will be explaining how the three phenomena are exhibited. So we have three discs. This is representing, the first one is representing the moon, due to moving on one side, and second one is representing Venus, due to moving on the left side, and then we have Mercury, and that is the Sun, the center. Now how does an eclipse occur? An eclipse occurs when actually the moon obstructs our view of the Sun directly. That is, the moon comes in between Earth and the Sun, and also the moon should be in one of its nodes, that is the orbital intersection of moon's orbit and the Earth's orbit around the Sun, at one of the nodes. So let us see, if you sit here and if you just focus on the direction of the Sun, and if I look like this, and if I bring this particular moon in my direct view, like this, I could not see the Sun for a particular duration, and then as the moon moves out, we again see the Sun. So when it blocks completely, we get a total solar eclipse, and when it moves out, we get partial solar eclipse. So this is the phenomena of a solar eclipse. Similarly, transits are phenomena when Mercury or Venus crosses the photosphere visible sphere of the Sun. So how do we see? So if you put it straight, we see that Mercury transit is occurring when Mercury, as it is moving in its orbit, passes in between Earth and the Sun, and it crosses the photosphere of the Sun. We say it as a transit. Similarly, when Venus crosses, we say that it is a Venus transit. So it is crossing, and it is a Venus transit of the Sun. So these are the phenomena of transit. Now what is an occultation? Occultation is actually temporary hiding of, means obstruction of the view of one of our inner planets. Inner planets are here, Mercury and Venus, and sometimes actually these inner planets go behind the moon. So in that case actually we could not see the inner planet, and it gets obstructed from our field of view. So how it happens actually? If you bring, for example, Venus is here, and if you bring basically what happens is that if you say our vision of this planet gets obstructed for a certain duration of time, and that becomes what is called an occultation. Similarly, we can have occultation of other stars or other objects in the sky. These are also very spectacular thing. Sometimes this planet Saturn also get occulted, and Jupiter also, exterior planets also get occulted when they're in the direction of our sun. So this exhibits explain the phenomena of eclipses, occultation, transit, and then directly interact